This is Nader Zaire, but it is not my voice. In this video, I want to introduce a new framework that helps you develop a RoboCup Soccer Simulation 2D team or conduct research in this area using any programming language while leveraging the power of C++. RoboCup is an international competition that promotes advancements in robotics and AI, challenging teams to develop robots capable of playing soccer autonomously. The Soccer Simulation 2D League, SS2D, focuses on developing intelligent soccer agents that play in a simulated environment by perceiving, deciding, and executing actions. The Cross-Language Soccer Framework, CLS framework, enhances the flexibility and interoperability of SS2D. It allows the development of soccer agents in multiple programming languages. Using the Soccer Simulation Proxy and Playmaker server, the framework connects agents built in various languages, enabling easier experimentation and development. Sample implementations are provided in C#, Python, and JavaScript, but any language can be used. This approach simplifies the complexity of working directly with the C++ base code, making SS2D development accessible to more developers and researchers. The RoboCup Soccer Simulator is a research and educational tool designed for studying multi-agent systems and artificial intelligence. It enables 2 teams of 11 autonomous software agents to play soccer in a virtual environment, emphasizing AI and team strategy without the need for physical robots. In the 2D Simulation League, 2 teams of agents compete in a virtual soccer stadium, represented by a central server called the Soccer Server. Each agent receives noisy sensor input and must decide on actions like dashing, turning, or kicking to influence the game. The challenge lies in processing these inputs and deciding on the best action within the game's 100 ms cycle. The focus of the league is on developing strategies and intelligent decision-making, highlighting the complexities of AI in dynamic environments. To run a game or participate in the Soccer Simulation 2D League, you need to develop a team of 12 agents and connect them using UDP to the RCSS server. Due to the complexity, it is challenging to develop a team from scratch, and using a base code is recommended. As seen in the video, players can move in 2 dimensions or kick the ball. Most of the rules are similar to real soccer, including charge fouls and offsides. Each game consists of 6,000 cycles, lasting 10 minutes in total. During each cycle, agents receive observations and must send a low-level action, such as dash, turn, kick, tackle, or catch. It is important to note that an agent can send only one main low-level action per cycle. However, they can also send several secondary low-level actions, such as, say, here, turn neck, and others, in the same cycle along with the main low-level action. As mentioned earlier, in each cycle, the server sends observations to the agent. These observations can be either normal or full state, and normal mode is used in competitions. In normal observations, agents receive noisy information about the flags on the field, such as the distance to flags within their view angle and the angle between the neck direction and the flag. Using this information, the agent can determine its position. The server also sends details about the distance, angle, and speed of objects within the agent's view angle. By combining this data with information from previous cycles and predictions, the agent builds a model of its environment called the world model. In full-state mode, the agent receives exact positions and velocities of objects without noise. The agent must choose an action based on the world model and send it to the server. However, the server does not understand high-level actions like shoot or pass. Therefore, the agent must convert these high-level decisions into low-level actions and send them to the server. To simplify team development, the RoboCup community has released several base codes to help you get started. Most of these base codes include observation modeling and decision-making components, making it easier to develop a team without starting from scratch. Some of the most popular base codes in the Soccer Simulation 2D League include Helios base in C++, the most widely used base code in the league, Gliders 2D in C++, an enhanced version of Helios base with additional features from gliders and fractals. Cyrus 2D and C++, based on Helios base, gliders 2D, and includes features from the Cyrus team. Right Eagle, C++, a well-known base code used by the Right Eagle team. Pyrus, Python, a Python-based base code which offers easier development but has performance limitations due to Python's speed. Most of these base codes are developed in C++, providing high performance and efficient processing within the 100 ms cycle. However, Pyrus, developed in Python, offers a more accessible option for those who prefer Python, despite some performance trade-offs. While C++ is a powerful language and widely used in the RoboCup Soccer Simulation 2D League, it presents several challenges. Lack of AI libraries. Unlike languages like Python, C++ lacks readily available and easy-to-use libraries for artificial intelligence and machine learning. For example, popular AI libraries such as TensorFlow and PyTorch have limited support in C++, making it harder to implement advanced AI algorithms directly. Complexity and learning curve. C++ is a complex language with a steep learning curve. It requires a deep understanding of memory management, pointers, and other advanced concepts. This complexity can be a barrier for new developers who want to contribute to the league but may not have extensive experience with C++. Development overhead. Writing and debugging. C++ code can be time-consuming, especially when compared to higher-level languages like Python. The strict syntax and manual resource management make development slower and more error-prone. These challenges make it difficult for new researchers and developers to work with C++ base codes. The cross-language soccer framework aims to address these issues by providing the flexibility to use more accessible programming languages, making the development of intelligent soccer agents more approachable. To address the challenges of using C++ and make the development process more accessible, we propose leveraging RPC frameworks like gRPC and Thrift. This approach allows developers to create code in any programming language while still taking advantage of the performance offered by C++. In this setup, the Helios base code acts as a proxy or RPC client, while the Playmaker RPC server can be developed in any language you prefer. This flexibility enables developers to use languages like Python, JavaScript, or C# to implement decision-making logic, while the high-performance C++ code handles lower-level interactions with the RCSS server. What is an RPC framework? Remote Procedure Call, RPC frameworks, allow a program to call a procedure, or method, on a remote server as if it were a local function. This is particularly useful for distributed systems, enabling communication between different components seamlessly. gRPC. Developed by Google, gRPC is an open-source RPC framework that uses protocol buffers, protobuf, for serialization. It supports multiple programming languages and is highly efficient, making it a popular choice for high-performance systems. Thrift. Originally developed by Facebook, Thrift is another open-source RPC framework. It allows you to define data types and service interfaces in a Thrift file, and then generate code in multiple programming languages, making it easy to develop services in a distributed environment. Protocol buffers and RPC methods. Protocol buffers, protobuf. Protobuf is a method of serializing structured data, used by gRPC to define messages and service interfaces. It is language-neutral and platform-neutral, allowing for efficient communication between systems. Thrift files. Similar to protobuf, Thrift files define data structures and service methods, which can be used to generate classes in various languages. Benefits of using RPC frameworks. Language flexibility. By using frameworks like gRPC or Thrift, developers can write server and client code in any language that supports these frameworks. This enables easier development and the ability to leverage the strengths of different programming languages. Code generation. Both protobuf and thrift files allow developers to generate classes in different languages, reducing the amount of manual coding required and ensuring consistency across different parts of the system. Performance. Using a C++ proxy for performance-critical tasks while implementing decision-making logic in a more developer-friendly language strikes a balance between performance and ease of development. This approach allows developers to overcome the challenges of using C++, making it easier to develop and experiment with intelligent soccer agents in the RoboCup Soccer Simulation 2D League. Helios base code and Playmaker integration. In the Helios base code, each agent receives observations, localizes objects, and updates the world model. Additionally, it updates models like the interceptable model, which calculates variables such as which player can reach the ball first and in how many cycles. Based on these models, the strategy is updated to inform the agent of its designated position, home position, or where it should move. Depending on the current game state, if the player is the ball owner, it initiates a kick strategy to decide between passing or dribbling. Otherwise, the agent chooses a movement strategy to move to its assigned position or intercept the ball. Move and kick strategies. For the movement strategy, the Helios base code uses a basic move approach. For the kick strategy, it employs either a basic offensive kick or a planner. The planner is an algorithm that constructs a large decision tree starting from the ball owner. It then finds the best sequence of actions within the tree and attempts to execute the first action in that sequence. Converting high-level actions to low-level actions. In the next step, the agent converts high-level actions into intermediate actions, such as body go to point or body smart kick. These intermediate actions are then further translated into low-level actions that the server can understand. Finally, these low-level actions are sent to the server for execution. Cross-Language Soccer Framework Overview. The Cross-Language Soccer Framework leverages the Helios base code as a soccer proxy. The proxy sends models as state data to a gRPC or thrift server, which acts as the Playmaker server. The Playmaker server, implemented using any preferred programming language, chooses the best decision and sends it back to the proxy. The proxy then converts the received action from the RPC server into low-level actions and sends them to the soccer simulation server for execution. Playmaker server implementations. Currently, we have developed Playmaker servers in Python, JavaScript, and C#. You can start by using these implementations or develop a new base code in your preferred language. This approach is much simpler than developing a base code from scratch, as it leverages the Helios base code as a proxy, allowing you to utilize the power of C++ performance while focusing on decision-making logic in your chosen language. Availability of CLS Framework, the Cross-Language Soccer Framework. CLS Framework provides several options for flexibility in connecting agents to Playmaker servers. Team connection. You can connect all players of a team to a single Playmaker server, simplifying the decision-making process for the entire team. Individual player connection. Each player can be connected to a separate Playmaker server, which is recommended for competitions. This approach ensures that each agent has dedicated decision-making capabilities. Training and machine learning. Agents from different games can be connected to a single Playmaker server for training and machine learning purposes. This setup is useful for reinforcement learning, allowing multiple agents to learn simultaneously and share experiences. Role-based connection. You can connect each player role to a specific Playmaker server. For example, all goalkeepers could be connected to one Playmaker server, which focuses on specialized decision-making strategies for goalkeeping roles. These flexible configurations enable different levels of control, specialization, and scalability, making it easier to adapt the framework to different scenarios, whether for competitions or research purposes. RPC services and actions. The cross-language soccer framework utilizes an RPC service to facilitate communication between agents and the Playmaker server. Here are some of the key RPC services and their associated actions. RPC service examples: Get player actions, state returns. Player actions. This RPC method allows an agent to request specific actions based on the current game state. The Playmaker server will determine the best possible actions for the player based on the provided state. Register request, returns, register response. This method handles the registration of agents with the Playmaker server. Each agent sends a registration request, and the server responds with a unique client ID. Agent actions. The RPC service supports several types of actions that agents can execute. Dash moves the agent to a related direction at a specified power. Kick kicks the ball with a specified power and direction. Body smart. Kick, a high-level action that aims to kick the ball intelligently towards a target, such as position of a teammate or goal with specific kick speed. Planner uses a decision tree to determine the best sequence of actions for the agent to take, allowing for more strategic decision-making. Basic move, a simple movement action that directs the agent towards a specific point on the field. These actions can be low-level server commands such as dash and kick, or high-level strategic commands like body smart kick and planner. The Playmaker server is responsible for selecting the appropriate actions based on the state information received from the agents, and these actions are then executed by the proxy. State message and world model. As mentioned earlier, the proxy converts the world model and interceptable data into a state message. The state message contains a field called the world model, which is an object that includes all the necessary information needed for decision-making. The world model object contains details such as the positions and speeds of objects like players and the ball, as well as other important information about the game environment. This comprehensive data allows the Playmaker server to make informed decisions on behalf of the agents, ensuring optimal gameplay performance. GitHub organization and repositories. Our GitHub organization hosts several repositories that are essential for using the cross-language soccer framework. Proxy. Repository contains the proxy code, which is the core component for connecting agents to the Playmaker server. We provide several sample Playmaker server implementations, including sample Python Playmaker server with gRPC or Thrift that demonstrates how to use both gRPC and Thrift in Python for decision-making. The sample C# Playmaker server with gRPC implemented in C# using gRPC. The sample Node.js Playmaker server with gRPC implemented in Node.js using gRPC. We also plan to release additional base codes in various languages, making it easier for developers to start working on their own agents using their preferred programming languages. These repositories provide all the necessary tools and examples to get started with the CLS framework, whether you want to use existing components or develop new ones from scratch. Development features. The cross-language soccer framework is continuously evolving to address compatibility and usability challenges. Here are some of the key development features. Cross-platform compatibility challenges. We aim to make the CLS framework compatible across different platforms, making it accessible to a wider audience. Windows compatibility, WSL, Docker. Currently, you can use Ubuntu or Windows with WSL to run the RoboCup server as an app image. This means you don't need to install it manually. Additionally, the proxy can be run as an app image, eliminating the need for building it from source, and the Playmaker server can run on Windows. RoboCup competition preparation. App image. To prepare for competitions, the app image format is used to simplify the setup process, allowing participants to focus on developing strategies without worrying about complex installations. Integration with GIM environments. We are working on integrating the CLS framework with GIM environments, which will enable researchers to leverage standard reinforcement learning tools for training soccer agents. Support for reinforcement learning research. The CLS framework supports reinforcement learning research by providing a flexible and robust platform for training agents. Agents from different games can connect to the same server to train collaboratively, sharing experiences to improve their performance. Currently, you can use Ubuntu or Windows with WSL to run the RoboCup server as an app image, so you do not need to install it manually. You also do not need to build the proxy since you can use the proxy app image. The Playmaker server can run on Windows as well. In the future, we plan to deploy Docker images for both the server and proxy, which will eliminate the need for Ubuntu altogether. Additionally, we are developing a Python framework using CLS Framework to support gym environments and reinforcement learning, making it easier for researchers to train and experiment with soccer agents using the latest AI techniques. CLS Framework Website Overview. Our CLS Framework website provides comprehensive documentation and resources to help you get started and continue your development journey. Documentation. Detailed guides on how to use the CLS framework, including setting up the environment, running servers, and integrating components. How to use CLS framework. Step-by-step instructions for installing and configuring all the components needed to use CLS framework effectively, from the proxy to Playmaker servers. Developing a Playmaker server from scratch. Tutorials on creating your own Playmaker server using gRPC or Thrift, allowing you to fully customize the decision-making logic for your agents. Additional resources. Everything you need to make the most of the framework, including FAQs, troubleshooting tips, and community support links. The website is designed to provide everything you need to get started with CLS framework, whether you are developing a new Playmaker server or just want to learn how to use the existing components effectively. Thank you for your interest in the cross-language soccer framework. We want to express our gratitude to all the developers who helped create this powerful and versatile framework. Your contributions have made it possible to bring this project to life. Don't forget to check out our GitHub repositories, read the paper, and explore the documentation to get started. The resources are available to help you develop and improve your soccer agents, whether you're just beginning or looking to enhance your current implementation. Start developing now and join the community.